we are talking about mole calculations, and on your sheet you are going to notice that there is some information about how you convert between moles and different units. So we can say that a mole of any compound is equal to its weight in grams. So in other words, it's formula mass of that compound. So you would obviously need a periodic table for that. Another thing we could say is that a mole is a count. So a mole of an element would be equal to 6.02 times 10 to the 23rd atoms of that element. If it's a compound, then you're going to say it's equal to 6.02 times 10 to the 23rd molecules of that compound. I know it says representative particles. We're just going to use the term molecule, but there actually is a difference. If it's ionic, it's called formula units. If it's covalent, it's called molecule. To keep things simple, we are going to use the word molecule. So that's what we'll stick with. Then there's a little place on your paper for you to draw something known as a mole map. And for the mole map, the key is that if you can get to a mole, you can go anywhere. So for you to draw this mole map, just write the word mole right there in the middle. And then we know that we can go back and forth very easily between moles and mass. And that mass is measured in grams. We know that we can also go back and forth between moles and number of particles. And in order to go back and forth between moles and mass, think about what you would use, what we talked about up here. So in order to go back and forth between these two values, we're going to use something known, I'm just going to call it GFM. Remember, there's many, many different ways to phrase it, but this stands for gram formula mass. So that's looking at your periodic table and adding up the masses of all of the elements within that compound. So that's one way we can use our moles, is to go back and forth between moles and mass. You can also go back and forth between moles and number of particles, and that is by using 6.02 times 10 to the 23rd, also known as Avogadro's number. He was that cute guy that we saw earlier in our slide. Okay, so that's what we're going to be looking at, and I'll kind of refer to this map occasionally here and there. So everybody has their calculators out, and we are ready to start. So this first one, it says, how many moles? Maybe on this first one or two I'll write this down, but then I'll probably stop doing that. Also, MOL is the abbreviation for mole, which is kind of silly. You drop one little tiny little letter, but there's really not an abbreviation for molecules. I don't understand that, but that's the way it is. So we're going to be looking for moles, and we know that we're starting with 18.0 grams of C6H12O6. So you guys will do great at this if you remember two things. If you remember nomenclature and if you remember dimensional analysis. That's really all we're doing, is just combining those two things. So we're starting off with grams of sugar. Well, you guys know how dimensional analysis works. You don't want it in grams of sugar, so what do? You put it down at the bottom so that it cancels out. There's our grams of sugar. What can you go to? Moles. We can do this in one step. We can go directly to moles because we know that 1 mole of any substance is equal to its weight in grams. So I look at my periodic table and I see 6 times 12.01 for carbon plus my 12 times 1.01 for hydrogen plus my 6 times 16 for oxygen. So you just, and that's what we did last unit, was we calculated that formula mass, gram formula mass, molar mass, whatever you want to call it. And you add it all up, and you get 180.18 grams of sugar. So at that point, we got our grams of sugar to cancel. We have our answer in moles. That's all it asked for, so that was a quick little easy problem. We just had to convert from grams to moles. If I were to jump back to our mole map, I could see that all I did was go back and forth. Well, that didn't show up very well. Go back and forth between grams and moles. And then you think about dimensional analysis to think about which unit goes on the top and which one goes on the bottom. Okay, so I guess we should actually calculate this. How many significant figures should our answer be in? 3. And for the sake of time, I'm actually just going to do this. We get 0.0999, and our answer would be moles. And this is where it sounds a little bit picky, but I really, really like to see the entire compound written. Whatever it's referring to, I want to see that. So moles of that sugar. And our reason being that later on in the year we talk about reactions, and we might start off with grams of sugar and end up with liters of oxygen or something like that. So there's different ways that we're going to be working through these. Okay, number 2. It says, what is the weight? Well, that's going to be grams is what we mean there. We're starting off with 4.50 moles of barium sulfide. And barium sulfide, everybody, we just did nomenclature. How do you write barium sulfide? Yes. There, I heard it. So it's +2 -2, so that's how you would write that. Okay, so for this problem, we don't want it as moles of barium sulfide, so I'm going to put that down at the bottom so that it cancels. What can we go to? Grams of our barium sulfide. So 1 mole is equal to, and then you have to look at your periodic table and you add up your sulfur and your barium, and 169.39. Quick reminder to you guys, remember on last lesson we said don't use the periodic table that's hanging on the wall because it's not really rounded the way that we just want to we want everybody to round them. If you just round them to 2 past the decimal, then it makes it nice and easy. Everybody should get the same answer. So I think I'm going to pause this and pass those out. Okay, so now what we see is that our answer, when we work this through, and I'm also kind of taking this for granted that you guys remember what to do as far as dimensional analysis goes. I'm not taking the time and the space to put in a little times there. But whenever it's in the top, you hit multiply, and whenever it's in the bottom, you hit divide. And our answer is 762 grams of barium sulfide. So that's what we get. So far, so good. Next one. We are looking for molecules, and we are starting with 28.6 moles of nitrogen gas. How do you write nitrogen? N2, because it is diatomic. Actually, if you missed that on this problem, you would see that it wouldn't hurt you. If we had a problem where you were doing something with grams, it would actually end up giving you the wrong answer if you didn't get that correct. But 28.6 moles of nitrogen, we don't want our answer in moles of nitrogen. We want it in molecules. So I'm going to hop back again. Can you go from moles to molecules, number of particles, in one step? Yeah, right here, that's what you do. So it's a one-stepper for us, and we know that our conversion factor is that 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles of that substance. So in this case, we're talking about molecules. And always good practice for everybody to plug this into your calculator and make sure you haven't forgotten how to use your scientific notation. And here near the end, I think I'm going to get some more class participation, but let me just go ahead and do some calculations on this. This is going to be 3 sig figs, so 1.72 times 10 to the 25th, and that would be molecules of nitrogen. Next one. Here we are looking for moles, and we are starting off with 3.90 times 10 to the 28th. That's molecules of methane. Okay. You know that you don't want molecules of methane, and that's typically what I start off with, is what's going to go in my denominator so that it cancels. Okay, what can you go to? We can hear the crickets chirping in here. What can you go to? Louder. Moles. So when in doubt, go to moles. So we know that 1 mole of any substance is equal to 6.02 times 10 to the 23rd molecules of that substance if it's a compound, like this. So now when you plug that in, I'm going to pause this and make sure everybody can get the right answer. All right, we got a winner, 6,480 or 64,800, and the answer would be moles of methane. Remember, we rounded that to 3 sig figs because of what our problem gave us. Let's also stop for a second and look at some things that we see. If you look within the work here, you notice with the mole, what do you always see? 1 is always with the mole. We're saying 1 mole of anything, unless you started with the moles. But 1 is always going to be part of your conversion factor, is what you see. Okay, next one. It's a little bit more complicated. Here it says how many atoms of oxygen are in 2.5 moles of oxygen gas. And the way you would write oxygen gas is O2. Okay, so we know that we don't want it as moles of oxygen. So I'm going to write that. And what could we go to? Molecules. Let's go to molecules. So we know that 1 goes with the moles. And what goes with the molecules? 6.02 times 10 to the 23rd molecules. So think about what we have to do first. We have to first go from moles to molecules, just like we've been doing. But now we've got a little bit extra step. We know we want to get rid of the molecules of O2, and all we really want is just the atoms of oxygen. So what do you think, what number do you think you're going to put down here in your denominator? In the denominator. 1 in the denominator. And then up at the top where you have 1 molecule of oxygen, you've got 2 atoms of oxygen for every 1 molecule of O2. Okay, so that's how we've got it set up. Then you do the math. And we come up with 3.0 times 10 to the 24th atoms of oxygen. Okay, I need to wake people up in here, so I think what I'm going to do is do this offline and then come back and show some answers, because everybody in here is going to do this themselves and it'll be fun. I'm going to pick on people. So we will be right back. Okay, so we just went through and did these few problems. I think we saw the ones before this. So you might want to pause because I am going to jump ahead and go on to the next page. Hopefully you guys can figure it out from there. And then we did number 10. We skipped number 9. Number 9 is very similar to number 10, except your aluminum fluoride, which you know is AlF3. Basically what you'd see is that for every 1 molecule of that, you have 1 atom of aluminum is what you have to do at the very end. And now we're going to finish this up by doing number 11, and it says how many moles of carbon are in 1.00 times 10 to the 20th molecules of propane, C3H8. And so for this, there's a little trick to this at the end also. We know that we're starting with molecules of propane. We don't want it in molecules, so that's going to cancel out. We put it at the bottom. And you know, if you were to look at your mole map, you would see that you can always go from molecules to moles. 1 mole of any compound is equal to 6.02 times 10 to the 23rd molecules of that compound. So that's where we've got it at right now. So you've got it as moles of C3H8. Well, we don't want it as moles of that entire compound. You just want it as moles of the carbon within that compound. So the last little trick is that you can get rid of your moles of C3 H8, and you can go to moles of just the C, just the carbon. Now remember earlier we said if this was one molecule of C3H8, one molecule, then you'd have 3 atoms. It's very similar. If you have 1 mole of C3H8, then you would have 3 moles of just the carbon, is what we're going to see. So maybe if you interchange the word dozen or something in your head, maybe that'll make more sense to you, but it works out that way that you've got 1 mole of that. So then we do the math, and we get our answer to be 4.98 times 10 to the negative 4th moles of carbon. That is about all I'm going to go through on these. Let me just kind of finish up with this other idea, and we talked about this a little bit before I started taping, but remember a mole is a really, really huge number. So here's another thought for you. If we were able to count atoms at the rate of 10 million per second, it would take about 2 billion years to count the atoms in just 1 mole. So it's a really enormous number that's hard for us to fathom. That is it for mole calcs.